Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. Today we are discussing DC rail and high power stage, driving stage, output current sensor, input current sensor. It is part of Omron 3G3SV BB015 VFD. In last session we discussed its input circuit, bridge rectifier, surge protection circuit and DC bank. These capacitors 400 volt 950 microfarad. These capacitors, if you have not watched that video, I will recommend to watch that video. Video number is displayed on the screen. When we receive positive voltage on this link, negative voltage on this link, it is output of bridge rectifier after passing through this surge protection circuit. These voltage reach on the both capacitors. Both capacitors are in parallel. Negative voltage will pass through this fuse. It is 500 volt 16 ampere DC link fuse. Positive voltage directly are reaching to this red wire and negative voltage are reaching through this fuse to this black wire. Both wires are entering in this component. Just only wires are working as a jumper from here to here, but around these wires there is a core. It is working as a transformer. On the ferrite core there is another winding that have two ends, this one and this one. It will tape voltage. Amount of current will produce relative voltage on these two wires due to this current transformer action. We can say positive voltage are coming here and these are reaching to pin number 1 of this IGBT power module. Negative voltage here. So these two lines will give us the value of the current, how much current is entering in this portion, because it is high power switching area. If any IGBT is short circuited, any pair is short circuited, or any one line, output line is short circuited, that will cause to draw huge amount of current. If there is overcurrent condition, it will damage everything. To protect from any unexpected damage, it will monitor the current. This current value will reach to analog to digital converter card. It is sampling card because it is using here 1052C196. This Intel microprocessor is specially designed to control the motors. It cannot understand the voltage value. It needs digital data. So this voltage value will reach to this card. This winding has 21 ohms resistance. Then this line is reaching here at this pin, and this line is reaching at this pin. On these two pins, both signals are reaching here, high and low. It will sample the signal and then it will convert this signal, analog signal, voltage value, because its amplitude is increasing all the time based on the current value. Then it will make digital equivalent value, analog to digital converter action in this pole. That digital data will reach to this microprocessor. It will become to know how much current is entering in this section. Pin number 1, positive voltage. This is positive link. Positive link is reaching here through passing this wire, and negative link is reaching to negative line, pin number 11, that is here, positive, negative. This IGBT module, its part number is MP6752. It's from TOSHIBA. It contains 6 IGBTs, high, low, for U section, for first phase, V high, low, W high, low. These positive voltage are reaching to high side IGBT collectors, U, V, W. Low side emitters of 3 IGBTs are connected to ground side, low side. Common point, emitter of high side, collector of low side IGBT is connected to output point. Same here, pin number 3 here is coming out, pin number 5 coming out, 7 coming out. Pin number 2 input for high side IGBT gate. 8 number pin for low side for U phase. Then V pin number 4 and 9. W 6 and 10. If we trace output signal, pin number 3. This is pin number 3. It is reaching at this point. Then it is entering into this winding that is wound on this ferrite core. Then it is coming out from this point. U signal here, then here, then here at this point, and it will reach at this output pin, that is here. Then pin number 5, that is reaching here. Pin number 5 is V. V signal, output signal is reaching here, then here, and it's coming here. Then pin number 7. Pin number 7 is coming directly here at this point. PCB underside, and it is connected here behind this bridge rectifier. This signal will pass from this point to this output point, this one. 7 is reaching here. This is 7. W phase is reaching directly to output point. U and V are reaching to this current sensor. It is output current monitoring circuit. How much current will flow in this winding? Its relative voltage value will reach to this card, and it will sample, amplify, and it will produce the signal at these two lines, this one and this one. This signal will reach here, this pin, and this signal will reach here at this pin. Both signals are reaching at these 2 points. As it is monitoring input current is entering in this portion. Output current is also entering in this portion. So it will monitor input current, output current, and it will convert into digital format the equivalent voltage value to provide this microprocessor, so that it will become to know how much current is entering in this module and how much load is connected on this module. If there is any imbalance, high input current, that means this module is damaged. If overload, the load is drawing more current, that means this module may damage due to overload. To protect this module, to protect the load, to protect the next circuit and all drive stage, microprocessor will ensure all parameters must be within limit. If any value becomes out of limit, that time it will generate error code and it will stop the drive signals. These are gate drivers for IGBTs. 1, 2, 3, 4, 5, 6. 6 IGBTs and 6 optocouplers, photocouplers, gate drivers. In upcoming video we will discuss its SMPS circuit, its sampling circuit, analog to digital converter, and we will discuss display card. Any code, any option that is to be displayed, it will be displayed on this 7-segment display. And we will also discuss how we can test this power module and how this module takes drive and how it works. I hope this video is informative. If it is good, give a thumb up. If you have any question, please write in the comments. Thanks for watching.